Well, hello, friends. Today, we are going to make some kind of a little sound player application for Serenity. So we already have one for the terminal, but it's a bit boring. Oh, wow, that's kind of a silly output. Um, but yeah, so we have this one called A-Play or Audio Play or whatever. And yeah, hopefully you could hear that old Windows 2000 startup sound there. But I would like to have a GUI app that can do the same thing so that when I'm browsing in the file manager, say, and I come across this file here, I'll just be able to double click it and it would pop up in some nice little player thing. So let's build something like that. And we're going to start by just making a new directory for it. So we'll call it, well, sound player. Sticking with extremely boring and obvious naming scheme. And then let's go there and I guess we'll just steal the make file from the file manager project because I'm a bit lazy like that. And I'll just edit it a little bit in sound player. And then we also need to make sure that we install this. So it's going to be sound player. One of these days, I'm gonna go work on the build system, I promise. And then let's make a shortcut for it as well, so we can start it easily while testing. So we'll call it SP. And then we also gotta make sure that we build this guy. So we'll just add him as a build target. Sound player. Okay. And then we need a main CPP here, and I think we're good to go. So let me just refresh my Qt Creator and player main. Okay, so here we are. Now we should be able to start working on this. So let's see. I haven't made a new app for a while, so we'll start by including G application, and I guess we're going to need to make a window, and I guess we're going to need to put some widget in that window. So let's just start out with these. Okay. So that's the very, very basic event loop app. And then let's create a window. Like that, and then we'll create a main widget for that, or we'll set a title. Sound player. Beautiful. And we'll make a main widget for it. So do window set main widget. And maybe we'll give the window a nice rect. How about we'll start at 300 by 300? I mean 300 coordinate, and the size will be 300 by 200. How about that? Okay. And before we do anything else, we have to window show. All right. Okay. And then we're going to want to load up some wave file, I guess, because we have a wave file parser, so we're going to use that. So that's in lib audio, a WAV loader. Maybe we'll get ourselves some, or actually maybe we don't need any of that. Let's see. Let's say if RC is not 2, or no. We'll allow starting with nothing, but say string path is RHV1, RC is 2, then RHV1, otherwise we'll just do home and on our Windows 2000 startup sound there. We'll just hard code it for now so that we can start the program easily. And then how the heck do you make a WAV loader? So you do a WAV loader with a path, and then you call load WAV with a path. That's weird. Wait, why is the API like that? Load WAV. Oh, it doesn't exist. Okay, well, that explains that. Then what we want to do is just create an AWAV loader, and then we can call get more samples to get samples from it. And we can also get the total samples and some other info here. So, okay, let's try that. So we'll say AWAV loader. It's WAV loader, or just loader, it's fine. Path. Okay, and then if loader. Wait, how do we know if it has an error? I guess if it has an error string. It's a bit of a weird API. Is that how you're supposed to use that? Wait, is nobody using these things? I want to look at aplay. What does aplay do? Make a WAV loader, and then just assume that it went okay? Oh. Maybe not the most beautiful solution. So when does this get set? M error string. So I guess M error string will only be set if there is an error. So let's just make this a little bit more understandable. Is null. Okay, like that. No, like that. Okay, this is just weird, but all right. Then we can call has error. And then we can fail, so we can say like stir. We're gonna need stdio. No, that's the line. Stdio. Fail to load lab file. Oh, has error, and then we can put the error like that. And loader.error string. Okay, turn 1. So if we can't open the WAV file, then we'll just give an error message and exit. Okay. Then if we can load it, I guess we want to start playing it, I guess. So for that, we're going to need a audio client connection. And I forget a little bit how these work. Client, audio client, let's call it. And then I think the idea is that you just call enqueue, basically. Right, so here we're just calling enqueue. Why is it like this? Oh, sys.io. Gross. Okay. So aplay, the command line tool, first we have to call handshake. This API is a little bit goofy. We haven't been using it that much yet, so it has some weirdness to it. I mean, you would hope that we could get the handshake to be automatic somehow. But the issue that I see immediately is that here we just do an infinite loop and we don't do any event processing while we're doing this, but instead we just block unqueuing the thing. So let's see. I guess we could have a variant. So currently enqueuing a buffer is a blocking thing, but we could easily, like it blocks on the client side here, you can see. So we try to queue a buffer by sending a synchronous enqueue buffer message to the audio server, and then if it succeeds, then we break. Otherwise, we just sleep one until we are allowed to queue up that buffer. We just block in here effectively, but we could easily make one that doesn't block, which would make it much more suitable for using in a GUI. I mean, ideally, we would get some kind of a message from the audio server that, hey, there's space in my queue now. So if you have some samples you want to queue up, then throw them my way. So maybe that's what we'll do. I'm not quite sure. But first thing we'll do, I guess, is just make a little UI. So how are we going to do that? We could just have, we could just show the samples as we're going through the file. Actually, that would be kind of interesting. So, let's do this with a timer first, and then we can build on top of that. G timer. No, it's not G timer. It's C timer. So, like, in my head right now, I'm like realizing all these things that are missing in the operating system that would make implementing this straightforward. So we may have to take some interesting shortcuts. We'll see what we end up with, because the way to ideally do this kind of application, a lot of that scaffolding is missing. So so we're just gonna have to work with what we have, which I guess is really part of the fun here in the project. So let's make a timer, and we'll say, we'll just have some interval, like every 100 milliseconds. We will call this timer, and this timer will, let's see, audio client and queue. We'll make a variant of this right away, so we'll call it try and queue. So try and queue can fail if there's not space on the in the server's queue for this sample buffer. So the audio server is a separate server process that mixes together sound from any number of sources. So like the idea is that every application can send sound to the audio server, and then the audio server will just mix everything together and send that to the sound card. So that's why we have to send audio to him here. And on the audio server side, there's for every audio client, there is a queue of samples basically. And what we're doing here is that we're just trying to add more to our queue, but the server only allows you to put so much in the queue before it says like, all right. So now we're making this variant here that we'll just return response success, and that will just inform the caller of this function how it went. That's good. Okay. So let's say try and queue. Okay, so how are we going to do this? Try and queue. We're going to need to have something to queue up. So we need an audio buffer here. So we get those by calling get more samples. So it's a very, very simple API right now. It doesn't let you customize anything. You can just like start at the beginning of the wave file, and then you can get more samples until it runs out of samples, and there's no way to rewind or to seek or anything like that. So we're just going to work with what we have. Guess we'll end up next sample buffer, and we'll say loader get more samples. Okay. We'll try to enqueue the next sample buffer. If enqueued, if not enqueued, then just return. Because then we have to wait. Otherwise, the next sample buffer is loader get more samples. And I guess this thing can return null. Yeah, right. So if next sample buffer, then we will say, we'll print a little message like, we'll put it on the debugger actually. Ran exhausted samples. Okay, and then sleep a little bit, I don't know, 3 seconds, and then we'll call app quit. Okay. So I have no idea how well any of this will work, so let's just try building it. I have to make everything actually, so let's just do that. I forgot to include a buffer. Okay, so sound player. And now samples, and we're good. Okay, so it's a little bit obnoxiously loud, so let me just, probably doesn't sound super obnoxiously loud on because the sound is going in from my speakers into the microphone, because I can't figure out how to set up OBS to record my desktop sound correctly on Linux. But anyways, that was, you know, stuff happened, so that's really good. Now I think that what we're going to do now is that we're just going to take, and by the way, this is what I was referring to earlier when I said that we're just going to have to build this with the mechanisms that we do have, because obviously, like, doing this on a timer so that like every 100 milliseconds you wake up and check if you can queue more samples is not really the best design. It's much better if the audio server could tell us like, hey, I need more samples, but we don't have that mechanism, and it would take me a bit too long to implement that right now. So, and we're already on a mission here, so let's just keep going. So let's make some kind of a GUI for this. Let's do a custom widget. So let's call it sound player sample widget. Maybe that'd be kind of cool. Sample widget. Yeah. I'm gonna have to add that to the make file. So I'll just do sample widget data. All right. And refresh creator. Okay, and then we'll include that here. And we'll make sure that we create one. So we'll do like, actually, let's set this thing up a little bit more. So let's do a widget, fill with background color, yes. Set layout, we'll do a, include the layout system. Box layout, all right. We'll do a simple box layout with vertical orientation. All right. And then we will make a sample widget. New sample widget, and we'll put that inside of this widget. Okay. Now, this thing doesn't exist yet, so we have to fix that. But the idea is that the idea that I have now is that we'll make a widget, and then when we queue up a different buffer and it succeeds, then we will just make that like the current buffer in the sample widget, and that will give us something to draw, basically. So here we'll just say sample widget set current audio buffer or sample buffer. Set current buffer. Set buffer. Okay. Sometimes the names should just be short. Right. So let's go and make this class. Sample widget. GUI will inherit from, I think, GFrame. Sample widget. Public GFrame. Actually, let's be final. And let's do that. Oops, no. Okay, and then we'll do a ref footer to a buffer. And we can just forward declare that, I think. And we'll also have simple widget constructor. Takes a parent. Make it explicit so that we can't accidentally construct one from a value. This is like, it's just a habit that I like to keep. It catches quite a few bugs, but it happens sometimes, and when it does, it's nice. So let's put that out of line. Okay, and then the interesting thing here is going to be the, we don't need protected because we're final, so we'll do paint event. That's the one that's going to be interesting. And we also need a set buffer. I guess null is a valid buffer, so we'll take a pointer and not just a reference. Okay. And I think, oh no, that's not what I wanted to do. I wanted to go here to CPP file. Sample widget. Oh, this is itchy today. Sample widget. Okay. I took a GWidget parent, so we have to pass that to our parent. And we did the destructor, and then paint event. Can I? No, I can't get a automatic. All right. Wait, why is this so weird? Oh, right, here we go. Okay, now we'll need a GPainter so that we can paint. Painter, and we'll paint on this. And then, I mean, the first thing actually we should do is GFrame, paint event. I think that's how you normally do that. Yeah, right. So because we inherit from GFrame, then we want to just paint a normal frame. So here we'll call it set frame shape container. Frame shadow is going to be sunken, and frame thickness will be 2 pixels. That'll be a good look. And actually, let me go and add a little margin to the main widget layout. Say 3 pixels. Is that a good look? Is that what we know? No, maybe 2 isn't enough actually. Let's try that. Okay. And then we also needed the set buffer. And then here we'll say if mbuffer is already buffer, then that's a no op. Otherwise, mbuffer is buffer and update so that we repaint. Okay, and then here, now we want to repaint. So I guess the first thing we'll do actually is clip the painter to the paint event so that we don't overdraw, because that's just silly. And then we can just fill the frame inner rect with black, and I have no idea how, yeah, we don't know how much audio is going to be in this thing. So I guess we can dump that out here, actually. Samples, sample count. M buffer. Oh, wait, what's in an A buffer anyway? An A buffer is ref counted and it has a sample count. Okay, so let's say if M buffer, otherwise we don't have to paint anything. In fact, if we don't have to do that, then we can just return here. Don't have to nest. Okay. Sample count. Looks like we need to include lip audio, a buffer. Okay. So let's have a look at it where we are now. So let's build it and run it. That didn't work because, oh, I call it with a reference. Okay, so when we exhaust the samples, let's just leave it alone. Okay. I was thinking, what should we do at the very end to make sure that it looks right, but don't have to worry about that right now. So, okay, so we got a heck of a lot of samples, but we also have a lot of pixels. So, I'm thinking, should we just compress the whole buffer? Or should we, maybe we could make it more interesting by telling this guy how many samples we want. I'm not really sure. Because this is so many samples. We're not going to show much, but let's try building this guy with a smaller size. Because it was reading like 128 kilobytes at a time from the WAV file, which is why we get so few sample buffers with many samples in them. And maybe it's better to just get like, I don't know, like a couple thousand samples. So we'll see how many we get here. 8,000 something. We can live with that. All right, so this should just be for our little testing project right now, and should be done in some different way later, probably. Should we tweak this? Maybe size T, max. See, max file read size, max bytes to read from input. Okay, max bytes to read from input. And get more samples, we'll have max bytes to read from input. And the default will be 128 kilobytes. Okay. I think we can live with that, but now we just have to do something differently here. So we'll even do 16K then, since we can do anything we want. And then we'll get many samples or sample buffers. So let's do something with them. So when we paint, let's see. So I guess we're gonna have a ratio between the number of samples and the number of pixels. So let's just calculate that. Like scale factor or scale. I don't know. I'm not good with this terminology, so I'll just call it factor. And that's the sample count divided by. And here goes a little Hail Mary stuff, just to make sure that we get a float number out. Excuse me. Frame indirect width. Okay, so that's how much we want to draw here. That's how wide each line should be, I guess. Does that make sense? But it's going to be less than 0. You know what? I'm just gonna do this the lazy way. We're just gonna draw the first set of samples, and then we're not gonna bother with the scaling it right now because I just want to get something working. So we'll just paint the first, and then we'll miss out on whatever comes after, but that's okay. So we'll do a simple loop here, something like buffer sample count. Actually, samples to draw. It's going to be whichever is smaller of sample count and frame interact width. Okay, then samples to draw. Okay, and then sample is buffer samples I. That's cool. What do we have in one of those? I have to look at it. So an A sample is a left and a right channel. So I think we're just going to draw the left channel right now, and we'll ignore the right channel just to keep it simple. What's the easiest way to do this? I guess I'll just draw a line. So we can even translate the painter actually to make the coordinate math a little easier. So we'll translate it by the frame thickness. Okay. And then I'll draw a line. Actually, maybe we should compute the lines. So 0.1 and 0.2. Color will be light, maybe green actually. And thickness 1 is fine. Okay, and then P1 is going to be, I guess, on the bottom. So maybe translating was a mistake. So frame interact bottom left translated by x coordinate y, I mean, and nothing in the y-axis. Okay, so that's where we. Wait, is that the whole thing? Yeah, I guess so. And then we do P2, which is has the same x coordinate as P1, but the y coordinate is I guess it is how big the number is It's just a float between, oh, it's between -1 and 1. So I guess then we should actually rather start in the middle. So that would be center. That's P1, center. Now we don't even, oh shit. Okay. So this one we can call X. And let's just do dots for now. So I'm gonna call set pixel. It's gonna be X, and then I guess it will be the frame interact dot center dot Y plus sample dot left times the height of the interact. I am so not confident with this type of math, so we can't use initializer syntax like that. We have to actually force the conversion with a cast. That seems vaguely sane, although maybe it should be reversed actually. So this should be a minus here, but we'll have a look. It's pretty nifty. So yeah, at the end there we should definitely clear the buffer somehow. So when we get to the end, we can do how do we do this? I guess we'll just say sample. Sleeping here is weird. Maybe we'll do sample legit set buffer null footer actually when we get to the end. Maybe that's okay. And maybe we don't quit automatically, we just leave it open. And maybe we add a little button so that we can quit when we want instead, just for simplicity. Do a little button. So let's see. Well, I guess we can just put that below. Say quit. And now we'll say button on click. Oh, wait, hold on. What's wrong with what I was doing here? Forgot to give it a parent. All right. Here we can do app quit. Okay. It's not going to be the most aesthetic, but we'll have a button. So the sound is laggy. I don't know if you can even hear it, but it's kind of laggy because I'm recording with OBS and it messes up the sound driver in Serenity a little bit. So it's something that we can probably improve, but it's not the focus of what we're doing today. But when I'm not recording, the sound is just fine. So let's see what this assertion here is. I guess it's this one. So actually we should do if no sample buffer. We'll do sample widget set buffer null putter return. And we don't have to do that down here. We can just do that. Okay, now we can leave those braces actually. And yeah, let's tidy up the layout a little bit. So we can say that this button is going to have a size policy. Vertically, it will just fill the available space, but horizontally, we'll set a fixed size policy. And for the preferred size, we'll just do 0 for horizontal because it's auto. But we'll do 20 pixels for the vertical. That'll shrink the button to look a bit better. There we go. Look at that. Isn't that kind of cool? All right. Now, let's go and integrate this with the file manager right away, just because that'll be fun. So here, this is how this works in the file manager. So in directory view, which is the big view class in the file manager, we have this thing called handle activation, which is what fires when you double click on an item, or if you press enter, I think also on a selected item. So it just looks at if it's executable, then we try to run it. And if it ends with PNG, we try to open it with a quick show. If it ends in anything else, we open it in the text editor. So I think here we will just do a very, very hackish if it ends in WAV. We'll say sound player. This will be very, very fancy. This is obviously super hackish and should work somehow differently, where we can have a registry of file types and associated programs that can open those file types. But it doesn't work like that right now. It's just hard-coded in the file manager. So let's see if we can open a WAV file. Look at that. Oh, it's so laggy. But it works. Very, 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 very cool. Okay, so I think that's as far as we're going to get with the programming. So let's do some commits. Let's see what we have here to commit. What did we change in aplay? Oh, well, that one, I'll just let that one go back to the way it was. I was just annoyed with my editor not syntax highlighting, but I don't care enough to commit that right now. So in the audio client connection, we did the try enqueue thing. So we can do that as a separate patch. So basically it works the same as enqueue, except that if it fails, it will just return immediately instead of retry in a loop until it succeeds. So we'll do a commit out of that. Let's say libaudio, add a client connection, try enqueue. Okay, this is a variant of the enqueue API that returns immediately and may fail. It's useful for when you don't want to block until the audio server can receive your sample buffer. Okay. And then we did some changes in the WAV loader. So let's look at those. So, right, so we were adding the ability to set the amount of data we read from the input so that we didn't have to do the hard-coded 128 kilobytes. And also adding a has error helper. So let's just add those in a separate commit as well. So we'll say libaudio make it possible to or allow what's the API called? Get more samples. Allow tweaking how much get more samples reads from file. Yeah. And this one we'll do last. Then we need to actually add those files. So that would be sound player. And it's this. Okay, so now we're talking about a program to look at here. Okay, so this is the makefile for the sound player. And here is the sample widget, which is a simple G-frame subclass that displays as a sunken container, thickness 2, very typical. Paint event, actually it doesn't need to log the sample count, sample widget. Let's say, fix me. Right now we only display as many samples from the buffer as we can fit in the frame error, right? Maybe scale the samples or something. I don't know, something, but I just want to move forward here. So, right, so the way this works is that we draw the frame, then we fill with black, and then finally we just plot the samples as pixels. And you could do this slightly nicer by using drawing lines, I guess, from like the previous sample to the next sample to the next sample. Maybe we should do that. I'm not sure. I'll just leave that alone for now. It's an idea for the future. We can put that as a fix me. This might look nicer if draw line instead. If drawn as lines. Okay, and then set buffer was just to assign a audio buffer to display, and that's why we call update here to make sure that we repaint after setting. Okay, and here is the definition of the sample widget. Very, very simple. Simple API. The only interesting thing it has is it stores a pointer to the buffer that we want to paint. Okay, and then down here is the program. So actually, let's get rid of that default, that it would open that by default, because that's a bit stupid. So instead we can say something here like if RC, let's do this for now. If RC is not 2, then printf usage. That file. RC 0. And then we'll just do this. And obviously this thing should grow up and do some proper stuff eventually, but right now, this is okay. Let's put that by himself. Okay. So if it works out, then we load it. If it has an error, then we fail. Then we connect to the audio server like that, and create a little window, put a widget in that window, add a little layout, put a sample widget into the widget, and then make a little quit button, shrink it a little bit, and just tell it to quit when we click it. And then we get the next, or the very first sample buffer here, and then we set up a timer that every 100 milliseconds tries to get more samples queued up in the audio server. And if it succeeds, we switch the sample widget to displaying the latest buffer. And when we run out, then we just print this little message, and I think that's good. And the rest is just setting up the install path and making sure that we get it built and everything. So I think that's a good patch. So add build file system. Okay, so here we'll say sound player. Start working on a GUI sound player application. Right now it can only play in. So play anything that a WAV loader can load. So obviously only WAV files at the moment. It works by having a timer that wakes up every 100 milliseconds, tries to send a sample buffer to the audio server. If the server queue is full, if our server side queue is full, and we wait until the next timer iteration and try again. We display the latest, the most recently queued sample buffer in a nice little widget that just plots the samples in green on black. All right. Cool. And then the last remaining thing in the file manager. So if we activate or double click on something that ends in .wav, you know, case insensitive, then we fork and open it in sound player. So file manager, open .wav files in sound player when activated. This makes it, now you can double click on WAV files in the file manager. Neato. Okay, so I think we're probably finished with this for today. So I'm just gonna do a full build here and we'll give it one last trial. See if I have anything else running here that I don't need running. Not really. Okay, we'll go from the file manager. Pretty cool. Pretty cool. All right. So I think that's going to be it for today's video. So if you made it this far, then I thank you for watching and for hanging out. And I hope you saw something interesting. And I will see you next time.